So we want to use the sum and difference identities to find the exact value, and you may need to use quotient reciprocal or even odd identities as well. So in looking at this one, first of all, down below here we have our sum or difference identities for cosine, sine, and tangent. If we needed the sum or difference ones for one of the other three trig functions, we would simply use their reciprocal function, compute the value, and then take the reciprocal. So looking at our example, we want the secant of 13 pi twelfths. Secant is the reciprocal function for cosine. So what I'm going to do is I'm first going to compute the cosine of 13 pi twelfths, finding it exactly, and then once I get that, I'm just going to take the reciprocal and I will have the secant. Well, thinking of unit circle values, since we need this exactly, we need to combine them to get pi twelfths, some kind of pi twelfths. So I'm going to take pi thirds and I'm going to take pi fourths and I'm going to convert those to twelfths. And so pi thirds in twelfths is 4 pi twelfths, and pi fourths in twelfths is 3 pi twelfths. Now I want to figure out a way to take multiples of those two angles, add or subtract them to come up with 13 pi twelfths. And there's more than one way to do it, but the one I see is if I take the first one, the 4 pi twelfths, and I add 3 times the second one, 3 times 3 pi twelfths, that would give me 4 pi twelfths plus 9 pi twelfths, which gives me what I need of 13 pi twelfths. So this combination will work to add to get me the 13 pi twelfths. So I'm going to do that with cosine, but I'm going to put them back in their reduced form so I can think of them on the unit circle. So 4 pi twelfths reducing by 4 is going to be pi thirds, and so we need the cosine of pi thirds plus the 9 pi twelfths, reducing those both by 3, that would be 3 pi fourths. So adding these two together gives me the 13 pi twelfths. I can use the sum formula for cosine then. Here it is, and it's going to be cosine of the first angle, cosine of the second angle. The way I keep the sign straight when the trig functions match, the sign between them doesn't. So then this will be sine of the first angle, sine of the second angle. Now I'm going to find these values. I'm going to think of my unit circle, and pi thirds is right here in quadrant 1, littler x, bigger y, so I know that one is 1/2 and square root 3 over 2. So I need the cosine at pi thirds, so that's going to be 1/2. And then I need the cosine of 3 pi fourths. Well, 3 pi fourths is over here. We know the pi fourths are square root 2 over 2's, but we also know in quadrant 3 x values are negative. So I need the cosine, so that's going to be negative square root 2 over 2. And then we have a minus. We need the sine at pi thirds, that was square root 3 over 2, and now we need the sine of 3 pi fourths, that's square root 2 over 2. Simplifying that, we have negative square root 2 minus square root 6. Common denominator there is 4. So that's what the sine of this would be. So the secant would be the reciprocal of that. So that is 4 over negative square root 2 minus square root 6. And I put that in parentheses because, you know, when you enter that in the computer, you want to let it know all of that is the denominator. So there it is in exact form. There's different forms to put it in, but that works. You would enter that in the computer then, and that would be the exact value for secant of 13 pi twelfths.